Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the area of a triangle. You probably already know the area of a triangle is base times perpendicular height over 2. Problem is you don't always know and can't always easily find the perpendicular height of a triangle, and that's particularly the case when the triangle's scalene. Fortunately though, there are other ways we can find the area of the triangle when we don't know the perpendicular height. So there are two ways we're going to look at in this video. One of them is using the formula A equals half AB sine C, and one of them is using what's called Heron's formula. So if you have a triangle like this, we have not the perpendicular height, but we have two sides and the angle between. So that's when we know to use this formula here. So the area of this triangle will just be half times A times B, and sine C is just sine of the angle in between. And you can put this straight in your calculator. We get about 33.8, and if no units are written, we just write units squared. So let's find the area of this triangle. Now we can use Pythagoras twice to find the perpendicular height, but it's pretty complicated. Instead, if you are given all three sides of a triangle, you can use Heron's formula. So when you're using Heron's formula, you first need to calculate S, the semi-perimeter. So it's just all of the sides added up, so in this case 7 plus 9 plus 10, divided by 2. So in this case, the semi-perimeter is 13. So to use Heron's formula, it's just going to be the square root of S times S minus A. It really doesn't matter which side you call A, which you call B, and which you call C. So it'll be 13 minus 9 times 13 minus 7. You can put this straight in your calculator. So we end up getting about 30.59 units squared. Right, let's now look at solving a problem involving one of these formula. So find the value of x if the area of this triangle is 30 centimeters squared. So because we have information about two sides and the angle in between, we know we'll use the formula area equals half AB sine C. So we're using that formula. Let's just substitute into this formula everything we know. So we know that A, area, is 30, and we're going to substitute A and B here for 8 and 10. Now it doesn't matter which you call A and which you call B. So A times B is 80. So we get 30 equals 40 sine C. Simply divide each side by 40. And if we want to undo taking the sine of something, we take sine inverse. So the angle here will be sine inverse of 3 over 4. So if we put that in our calculator, making sure we're in degrees mode, we get about 48.6 degrees. So here C, the angle in between, is just x, so we conclude that x is 48.6 degrees. All right, let's now look at Heronian triangles. So Heronian triangles are triangles whose area and side lengths are integers. So these are, I guess, a bit special because when we use Heron's rule and we're taking the square root, we usually get an irrational number for the area of the triangle. But there's a way that you can construct these Heronian triangles. So what you do is you use right-angled triangles and just put them back to back. So for example, I know that we can have a right-angled triangle that is 3, 4, 5. So if you put two of these triangles back to back, both of which are 3, 4, 5, you end up with a triangle that looks like this. It will have two sides 5, and its bottom there will be 6. So if we were to use Heron's formula to calculate the area here, S would be 5 plus 5 plus 6 over 2, which is 8. And so the area would just be 8 times 8 minus 6 times 8 minus 5 times 8 minus 5. And if you put that in your calculator, you get exactly 12. So this is a Heronian triangle. Its side lengths are integers and its area is integer. So that's how you find or construct an isosceles Heronian triangle. What about a scalene one? Well, to do that's a bit more complicated, but we can do it if we know of numbers that are in more than one Pythagorean triad. So an example of such a number is 9. So we know that we have a right angled triangle. 9, 12, 15 is a Pythagorean triad. There's also one that looks like this. That is 9, 40, 41. So we can put these two back to back so that they will form a Huronian triangle. So the number that's common 9 will be the perpendicular height. So we will have one side being 15, one side being 41, and on the bottom we will have this one here will be 12, this one here will be 40, so the total length there is 52. And if you use Heron's formula on this, it turns out the area is 234 units squared. So this is Huronian. It has integer side lengths and an integer area. Usually when you use Heron's formula, you get an irrational answer, but sometimes you get a rational one. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.